Okay, so how can you answer any A-level, OCR A-level linked list past paper question? But what I've done here is I've taken the past paper question from 2020 and from 2019 a little bit later on. And we'll talk about how linked lists work. It's fairly simple. You should understand that concept by now. But where it gets a little bit more tricky is when you get onto having to answer questions about the coding. So when it gets down here, so one of the questions is, how do you write the steps to find node path? How can you iterate through this linked list looking for a certain item and check it? All they want you to do is write down the steps, but to be able to do that, you need to understand how we loop through a linked list. Say when we've printed a list, or when we're trying to delete an item, because deleting an item is looking for an item and then updating the pointers to point to the one after once we found it. So you need to remember that code to go to the next pointer in the list and then check that. And you need to kind of know how to combine it. And then also the other type of question that I've seen on linked lists is one which uses 2D arrays. So that is one from the 2019, and I'll discuss that a little bit, talk about some of the code, talk about how a 2D array works. There's also another article about 2D arrays, which is linked in this. So yeah, let's get started. So we've got this one. Barney is writing a program to store the data in the linked list. He is writing the initial program for a maximum of 10 data items. So each node in the linked list has a data value and a pointer to the next item. So for example, at index 0, the data item is 2.6 and the pointer is 3. So it's we're going to go to 3 next. Then when we get to 3, 6.9, it goes to 2, 1, we go to index 1, and then we get to the end of the list, -1. So the first question, which you should easily be able to answer, is what's the head pointer and the free list pointer? Well, the head pointer is index 0, points to the head of the linked list, and the free list pointer is the next available space. So that points to 4. So that should be fairly straightforward. You can also see the model answers as the kind of things they want you to answer. So what about deleting from a linked list? Well, if you remember the code that we went through previously, or you should have done it, when you delete a value, you look for the value. Once you found it, you update the node before that one to point to the node after the item that we found. So current node next points to current node next, so the next one in the list. So that's exactly what we do here. So if we're going to, the question is, if we delete that value 6.9, this one, what we need to do is we need to follow the pointer to, so it goes to here. Well, originally it was going to, at index 0, we were going to go to 3. But instead of index 0 pointing to 3 now, we're going to point to 2. We're going to point to the one that this was pointing to. So if you remember, 3 was pointing to 2. So now this one is going to point to 2, so it'll skip that out. Now, they also ask you to update the head pointer. The head pointer stays the same, but the free list pointer, if you look at the model answer, it can either be one of two things. It can be the next available space, which is now at index 3, or that's like the most closest to the beginning available space. So that's now empty and we want to fill it, else we'll get holes and not use the linked list properly, or you can still point to 4. So again, go and have a look at the past paper question. And then they ask you about nodes. How do you write out the code for a node class? Again, you just need to remember the code that we created here. Every node in the linked list, or most of the data structures, they have a data item and a pointer to the next item. So that's very simply just written out like that. So there shouldn't be any problem there answering those kind of questions. But when it comes to find node path, this is where things get a little bit more tricky. So the question asked here is the function find node path takes the data item to find in the linked list as a parameter and follows the pointers to the required node, right? So we pass in the value that we want to find, and then we follow each pointer until we get to the node we want. The function returns the array of indexes of all the nodes it's visited, so you need to keep a track of every node that you visited. We're going to do that by concatenating a string of, so like, you visit 0 node, then you visit node 2, then you visit node 3, so you add it on, and it joins this to a suitable message stating whether it's found or not. So basically, your function's got to return a string with all the nodes it's visited, the indexes of the nodes, and whether it's found it or not, right? So, and all you've got to do here is much simpler. You don't have to write any code, but you need to remember how we loop through a list. So you need to remember that bit, and then you're just going to need to. So they like to test you a little bit, and they like to add a little bit on to see if how competent a coder you are, and you need to think about how you could solve this problem. So but they're only asking you to write down the steps. So they're not asking you to write the code, but you would need to remember the code that, for example, that we wrote here. Delete with value has most of the code that we need. So if we're going to with delete with value, we're passing in this data item here. So, and then we're checking to see whether the head pointer is null, i.e. the linked list is empty, and then we're checking to see if the head pointer is the data item we want. If it is, we actually return. Of course, here we'd need to store the items, the indexes of the items that we'd already looked at in the linked list, and return that with the message we found it. And we do this because we don't want to iterate through a list that, well, we can't iterate through a list that's empty, and we don't want to iterate through a list where the thing is at the beginning. It saves us some time. Then after that, you've got to copy the head pointer to a current node, right? Like this, and then you've got to basically do a while loop, and you while loop through until you either found the node you want or you reach the end of the list. So loop through while the next node is not null or we found the item that we want, and then we're going to look at the current item to see if it's the one we want. We're going to save the node pointer concatenate it in a string. And then if the item is the one that we wanted, we're going to return that concatenated string of nodes plus a message saying found or not found. If not, we're going to go to the next node. So that's all. You've just got to think about how could you solve this? What things do you know about variables and concatenating strings and whatever, and write down some steps. And if you don't get 100% correct, but the best thing to do is to write down all the steps. I've gone and had a go at writing the function for this, which you might want to have a look at. So public string find node path. So we pass in the target, and then we're checking to see if the list is empty or the thing is at the data item. So I might actually need to change that code a little bit. I just noticed a slight mistake in it. I don't know if you could see that, but basically we've got this string variable here, and I'm gonna start that at the beginning of the function, and then what we're going to return here is at each point I'm not returning something, so I want to return that I've not found it and the indexes that I've gone to so far. Well, if the list is empty, we won't return anything. However, if that is that, we're going to update indexes, and we're going to add on remember if you remember in the question before, with the node, to get the data item at that node, we used a helper function get data or get pointer and set data set point because they're private. So we're going to get data, call the function get data to get the data, get pointer to get the pointer. So I'm going to go head pointer dot get pointer, and that's going to return that. And I'm going to add that to indexes. I'm going to concatenate that string, probably put a comma between them like that. Um, and then we're going to return that, but we am saying that we have found it. So that's if the item we found is at the beginning, is our head pointer. However, if it is not, we're going to need to loop through this array. So we're going to copy this head pointer to a temporary variable, current node. And while the current node is not at the end, while it's not -1, we're going to loop through this. And on every loop, we're going to update indexes, and we're going to add on the current pointer, again, exactly like we were doing here. And then we're going to check whether the data item for that current node is equal to the target. If it is, we can just immediately return the indexes and say it's found. However, if it's not, we need to use this temporary variable current node and get the next item out of it and then update that and then go and do this while loop again. And we keep doing that until we reach the end of the list, until it points to -1, in which case we know that we've not found it. So we're going to return indexes and say not found. But you see, all you need to do is like just think on your feet a bit and print out that. So it's worth having a look at that code. It's definitely worth remembering how you loop through that linked list. It keeps coming up time and time again, so it's really important. And have a look at the model answers. So printing a linked list by following the next pointer. Well, the next question they ask you is, what's wrong with this code? They want you to identify all the different 3 errors. There's more than 3 errors, but they want you to identify 3 errors here. This is not, this bit of code is just printing, whereas this bit of code was looking for something and returning. So this is actually a little bit simpler, but again, it's looping through a list. So the first error is actually here. We don't need to -1. We just need a temp pointer to hold this head pointer. It's going to point somewhere, and that's what we're passing in. And then we've got this string, which we're going to use to add on the data item. So let's just check the question. So the next error is, instead of pointer here, it should be temp pointer, because a while linked list temp pointer. So the item at temp pointer, its pointer, while it's not equal to -1, while we're not at the end of the list, we want to keep looping. And then the next error is here, because on every iteration of the while loop, we want to update temp pointers so they're the wrong way round. And then finally, the last error is there's 1 stray bracket. So either we need to add a bracket on here, or we need to take it off from there. But again, this code here is basically just looping through a linked list. So you should be able to recognize it, understand how it's working, that it's looping through this linked list, getting the pointers until it's -1, and then concatenating this data item to print. And then after that while loop is finished, we're going to print that data item. So it's going to print out the whole of the list there like that. Yeah, so so again, understanding this looping of the linked list, how to get the next pointer to get the next pointer. So the last question that I wanted to look at is this. And to understand how to do this, you need to understand 2D arrays. Now, there is a link in this article, and I'll also link it in the video below. And the question starts off by using a data structure, a tree, and they ask you to output this into a table, and then in order traversal. So starting at the leftmost item, because that's going to be the first one in the alphabet, begonia. It goes begonia, daisy, hosta, lily. But we want to output this into a table. So we want to begonia at index 0 is going to point to daisy at index 2, daisy is going to point to 2, hosta is going to point to 3, Lily's going to point to 4, Peony, Rose, Sunflower. So that's alphabetical order. And you can see that is that in the tree. And Sunflower being the last one, so it points to null. So that's fine. Similar to the one before, there's another question about how do you delete from that. Like say, I think it was deleting pasta. And obviously, as we said before, or how would you add to that? We need to update the pointer. We're going to add to we need to work out the position of the new item and then update the pointers to point to that. But the most tricky one here is, again, not that tricky if you understand how to iterate through a linked list. But they're basically saying the linked list is stored as a 2D array. So a 2D array called plant list. So imagine this whole table is plant list, right? The index of the first element of the linked list is stored in first element. So to get the index of the first element, that would be 0. And that's stored in first element. We're going to use that index, first element, and then we're going to just follow its pointer to go to the next one and output each one in turn. But it is stored as a 2D array. So you might want to remind yourself by looking at this link, this article on data structures on. I might need to update that. That's not the right link, but this article here on 2D arrays. How does a 2D array work? But in summary, plant list 00 will return the data item. Plant list 01 will return the pointer to the next item in the linked list. So if we look at this table, each row is linked list item 0. And then that would be the first index. So what row we're on, 0, 1, 2, 3, 4. And then the next index in a 2D array is the column. We're either going to be 0, 1, 2, 3, 4. In here, we've only got 1 and 2. So if we wanted to have more columns, then we'd have more, but we only have 2. At 0, 0, we've always got the data. At 1, 0, we've got the data. At 2, 0, we've got the data. At 3, 0, we've got the data. At 0, 1, we've got the next pointer. At 1, 1, we've got the next pointer. So the first number is the index or the row, and the second number is the column. So how can we use that information then to write this algorithm? So maybe you want to pause the video and have a think about that. What you want to do is you want to remember, how do you iterate through a linked list? What's the stopping condition? At the stopping condition, if you have a look at the linked list code again, with this delete with value, or the print one, the stopping condition is we keep looking at the next node until it's not equal to null. So, so as it says in the question here, first element, the index of the first element, linked list is stored in first element. So we could, this is my code that I had to go writing, first element, and it's going to point to 0, right? And then we're going to copy that into a temporary variable, and I'm going to keep while looping until the current pointer is pointing to -1. I've got to the end of the list. And then I'm going to print out the data item. So again, how do we get the item from plant list? How do we get the data from plant list? Well, we need to use current pointer, which we're going to update every time. And first it's 0, and then we're going to point to column 0. So row 0, column 0, begonia. And then we're going to print that out. But then we need to update current pointer. Now, because this is C#, I have to basically I've stored these as strings. If you look at the full code for this, which is also linked here, I've got a plant list, and both of the things in the plant list are strings, but this is a number. It's always going to be a number because it's a pointer to the next index. So I'm actually converting that. That's the only reason I've got that there. So you wouldn't have to remember that. They're just asking you to write it in pseudocode. But then I need to get the next pointer. So how do I get the next pointer? Well, I use the current pointer as the row, and then I go to column 1. So current pointer 0, column 1 here, and that will get me the next pointer, which will point to here, to Daisy. So and then I keep updating that current pointer until it equals null or -1. And then once that's happened, I've outputted all of the list. So again, to answer this question, you need to understand how you iterate through a linked list. So go through these questions, look at the code, make sure you understand it, and have a look at the model answers. And that is how you will be able to answer any question on the linked list. Knowing how to update pointers, knowing how to loop through bits, knowing how to loop through a linked list until we get to the end, and being able to maybe think on your feet a bit when they're asking you different questions like, could you return the number of indexes? How are you going to store that? Just concatenate the string. Just have a go at it and do what you think is best, and you should be able to answer the question.